My name is Scott Dow with Aerotec LLC out of Birmingham, Alabama. I'm the Director of Operations in charge of all data capture missions. Most of our client base, probably around 90%, is electric utility industry. Then we do go out into government agencies, NASA, the Department of Defense. We're excited about the IP-S2 because it adds another dimension to what we currently offer our customers. Currently we're from the air with some ground support, but not at the detail that our aerial is. So what we're getting from the IP-S2 is a very comprehensive data set from the ground, allowing us to look under features that we can't capture from the air.
I'm Jim Dow, and I'm the founding CEO of the company, and it's my job to be sure that we always obsolete ourselves and somebody else doesn't obsolete our products. Aerotec is a model builder. We're not a data provider. We build models for engineering purposes. And so to build the best model, what you have to do is recognize the features of the model that you're building, and you also have to be able to do high resolution quality measurements within that model. The advantage the IP-S2 gives us is that we're not spending all our time trying to build a point cloud that we can recognize all the features with. We use an image for what it's good for, and that is recognizing features of our models. We use the LiDAR for its best quality, which is measuring the features of our models. That's it. It's put the right technology with the right application.
From the security perspective, what you're looking for is angles, attack angles where a sniper may be. It allows you to build a three-dimensional model that now you can run through all of the what-if scenarios. Where do I need security cameras to cover this whole corner? Now you're reducing cost of equipment in terms of placing too many cameras, or now you're making it more secure by adding the cameras that you need so there's no voids. You can measure in the heights of the buildings, the distance across streets. All of that data is very valuable in building a secure environment. When we don't use the IP-S2, then we're washed out. We have holes in the data. So when you're spinning things around in the three-dimensional world, there's missing data pieces. That's one of the biggest things that drew us to a rapid mobile system. So we're able to fill the void and then extract what we need when we need it and bank it and then use that other data for later purposes. It extends the lifespan and it lowers costs because we're capturing everything that we need or don't need at this time. We're capturing today, and the data is good for years. If we had flown it just from the air, you would see definition on the sides and the tops. You may not get the bottom depending on the angle of the helicopter when it passed. With the comprehensive data set, you can zoom in onto very small pieces of equipment inside that substation. You can pan around as a user for a GIS type application, pan around and be able to locate the bottoms, locate the tops, measure the heights of the poles, and from one spot spin around 360 and pick up all of the equipment that's located inside that substation. Whereas traditionally somebody would go out there and shoot a bunch of dots, and it's very non-intuitive to a user at the desktop. So what you're really creating a virtual survey in its truest form, and that person doing the data analysis may never have seen or ever have a need to see that particular substation, but can be just as effective as someone standing on site. You go back to traditional survey techniques using total stations or equipment along those lines, where you're actually got a guy with a rod and he's walking out sticking a pole down and shooting reflectors. Great method. It's just if you're trying to cover large areas, it's not time efficient or cost efficient to be doing that over thousands of acres.
Speed is the issue, okay? Let's get the right level of density, point density, up from the ground, combine that with the right point density from the air to adequately describe the models that we need to build.
The photo is very handy in that it allows you to rapidly locate items of interest: fire hydrants, manhole covers, electric utilities, whether it's poles, wires, transformers. Having the photo and the LiDAR together as one unit allows a complete range of applications, from the basic GIS data collection all the way through to the precision of the LiDAR. Now the photo is comparable to the LiDAR in terms of accuracy. One of its biggest advantages is the rate that the data can be captured. We were capturing 360-degree imagery plus the LiDAR data from the scanners all simultaneously, and we're capturing hundreds of thousands of points a minute. Traditionally, you're capturing a point every 25 feet, and you may get 10 of them in an hour. So we're covering miles where most people are covering feet. The data in terms of volume is substantial. The engineers like it because now they don't have to go visit the field.
This will open up other avenues for us. Even in the utility industry, we see applications like substation 3D modeling, relocation of facilities, much larger industrial sites like refineries.
Distribution, which we can't do from the air. It allows us to get under the lines, under the trees, so that instantly throws us into another market that we've been trying to get into in the utility business.
So now you have a much faster, higher quality way to rapidly model the effects of construction or any as-built facility.
What excites me personally with the IP-S2 is it takes us to a whole new level, a whole new dimension in the data sets at the speed of which we're able to gather them and merge them has not ever been done before. So it's true cutting-edge Star Trek type technologies all coming together to create this virtual three-dimensional world that we're living in, and you can reach out and touch it from your computer desktop as if you were standing out in the field in person, spinning around in circles looking at all of these features.